Okay, so on this first lesson in Unit 2, we're going to be looking at function transformation rules. And really these rules apply to any type of function that we've gone over, but we're just going to be looking at absolute values. So this first section you need to look at for your key concepts for each type of transformation. So we're going to look at the first example. We are given the absolute value parent function, and then we're given a new function, g. It says g of x equals negative absolute value of x. So what we're going to be doing on these examples is we're going to be comparing them and figuring out what type of transformation happens whenever we adjust our parent function. So it says on it, number 1, find the table values for g by... Now, anytime you put a negative on the outside of your absolute value, what you're going to be doing is multiplying your y values by -1. So anytime that negative's on the outside there, we're going to be multiplying our original y values by -1. So we first need to go ahead and fill out our table for f. So notice the x values are already filled in, so we're going to plug in a -4 for x. Absolute value of -4 is +4, because that's how far it is from 0 when you take the absolute value. When I plug in -2, I get 2. When I plug in 0, I get 0. 2 is still 2, and 4 is 4. So those are going to be my points that I'm going to use here for my f function. So I'm going to go ahead and plot those. -4, 4. -2, 2. And if you don't remember, your absolute value parent function is a v, and it crosses at 0, 0. So we need to connect those points and draw arrows. So there's my function f, which is my parent function and absolute value of x. Now, I told you to find the tables for g. If there's a negative on the outside, you're multiplying your original y values by -1. So I'm not going to change anything about my x's. So I'm going to go ahead and just fill those in. But now I'm going to multiply my original y values by a -1 because there's a negative in front. So now I'm going to have a -4. I'm going to have a -2. That doesn't change anything. I'm going to have a -2 and a -4. So I'm going to go ahead and plot those points. So I have -4, -4. I have -2, -2, 0, 0, 2, -2, and 4, -4. Connect your points. And this is my function g, which was negative absolute value of x. Okay, so we graphed f and g on the same grid. We're going to describe the transformation. So notice here that our v, which was our parent function, was reflected over the x-axis. Okay, so on these notes here, we're just going to try and figure out what happens whenever we adjust our parent function. So let's move on to the next example. So this one, notice we are starting with our parent function, absolute value of x, and we're going to graph g, which is going to be the absolute value of -x. So anytime we put a negative inside the vertical bars, your absolute value bars, you're going to be multiplying your x values by -1. We're going to complete the table. So my table doesn't change on my parent function f of x equals the absolute value of x. So 4, 2, 0, 2, and 4. So now what I want you to do is I want you to multiply the original x's by a -1. So you're multiplying all these by -1. So I'm now going to have 4 and 2, 0, -2, and -4. My y values are going to stay exactly the same. So 4, 2, 0, 2, and 4. So we're going to plot our points from function f, -4, 4. Which is just our parent function. And now we're going to see what happens whenever we put a negative inside with the x. So I'm going to plot 4, 4, 2, 2, 0, 0, -2, 2, -4, 4. So notice it ends up being the same, but what's really happening, notice these points up here were not the same here. So these points were reflected to get these points across the y-axis. So if we put a negative on the inside, that will be a reflection over the y-axis. So basically we're doing some investigation on these to figure out what happens whenever we adjust our parent function. Okay, let's take a look at another example. These notes are super long, so we will be doing these in 2 days. Our next example, we have still our parent function, absolute value of x, but now we're going to put a 2 in front of our absolute value of x. So if that happens, what you're going to be doing to find the table values for g is you will be multiplying the y values by 2. So my parent function is staying the same, 4, 2, 0, 2, 4. And then we're multiplying the y values. So we're keeping the x values the same. They stay the same. And then to get my y values, we're multiplying my original y's by 2. So that's going to be an 8 now. That's going to be a 4. That's going to stay at 0, 4, and 8. So now let's plot our points. So my original, which is my parent function, staying the same as all the others here. We're just going to graph both of them so we can see what's happening. -2, 2, 0, 0. So there's my function f. And then we're going to graph our new one. So -4 will now be, instead of 4, it'll be 8. -2 will be 4. 0, 0 will stay the same. 2, 4, and 4, 8. Okay, so notice that my 0, 0 point didn't change. So notice that it's stretching my y values. It's making them larger if I'm having to multiply it by 2. So this is called a vertical stretch by 2 because you're having to multiply your original y's by 2. All right, let's take a look at the next one. So notice, again, we're always starting with our parent function. That's why parent functions are very important. Now notice that the difference between the last example we did and this example is instead of multiplying it by 2, we're going to be multiplying it by a half, which is the same thing as dividing by 2. So in order to get our G values in the table, instead of multiplying by 2, we're going to be multiplying by a half. So we're going to complete our table. We have just our parent function that we know those points for. And then my x values are not going to change, just carrying those over. My y values, however, are going to change. I'm having to multiply my original y's by a half, which is the same thing as dividing by 2. And that will give me my new y values. So 4 times a half, or 4 divided by 2, is 2. 2 times a half, or 2 divided by 2, is 1. 0 times anything is 0. That one doesn't change. 2 times a half would be 1, and 4 times a half would be 2. Now, this is just an easy way of finding these points. You could easily plug those x values in here and then take the absolute value of x and then multiply it by a half. So you're welcome to do that as well. All right, so I'm going to go ahead and plot my parent function, the same as all the others that we had. So there's my parent function, and now I'm going to plot my function g. So -4, instead of it being 4, it's going to be 2. -2, 1, 0, 0 stays the same, 2, 1, and 4, 2. So notice the V gets wider. Okay, so the transformation for this is going to be a vertical compression by a factor of a half. So a vertical compression by a half. So it's shrinking those y values. It's because you're multiplying it by a half. So it's called a compression. Stretch, you're going up, it's a vertical stretch. Compression, you are shrinking them, so making them smaller. Okay, moving on to the next one. Notice here we're also using another 2 again, but notice on this one the 2 is on the inside of the bars instead of the outside, so this is a little different. So up above it was on the outside of the bars. So on this one, in order to come up with your tables or your values in your table of G, you're going to be multiplying the x values by, instead of 2, you're going to multiply them by a half. Okay, so filling in my parent function, still using the same one, absolute value of x. And then what we're going to do to get function g is we're going to multiply our x's by a half. So that would be a -2. That would be a -1. That would be 0. And then 1 and 2. And then our x's are going to stay the same. So 4, 2, 0, 2, 4. Okay, so we're going to plot the points. So starting with our parent function. Now we're going to plot our new points. We have -2 and then 4. -1, 2, 0, 0, 1, 2, and 2, 4. Okay, so on this one, for our transformation, if you're multiplying by a number in front, a coefficient inside the vertical bars, that is called a horizontal shift. It's either a vertical or a horizontal compression or horizontal stretch. So if it's a whole number, it is a horizontal compression by a half. The reason for that is because in order to get your new values, you're having to change your x values. X is our horizontal, and then you're multiplying it by a half. So the compression is by a half. So it's really the opposite is what it looks like on the actual equation there. Okay, so the next one, we have our parent function, and then we have our new one. Notice inside is a half. So you should be able to know now what we're going to be doing. We're going to be multiplying our x values by 2 instead of a half. Okay, so I'm going to fill in my parent function. And then I'm multiplying my x values by 2, so that's going to be -8, -4, 0, 4, that's +4, and 8. And then just keeping my y values the same. So plotting our points, -4, 4, -2, 2, 0, 0, 2, 2, 4, 4. So there's my parent function, and then plotting my new points, -8, 4. And then -4, 2, 0, 0, 4, 2, and 8, 4. So notice this is shrinking like the last one that we saw up above, but this one is not a vertical. This is called a horizontal because you're having to adjust your x values. So horizontal, and this is a stretch because you're multiplying it by 2. Okay, let's flip on over and look at some more transformations. Okay, so now notice that we have our parent function and we have our new function. We still have absolute value of x, but we're adding 4 on the outside. So if we do this, if we're adding 4 on the outside, that means from our table, we're going to be adding 4 to the y values. So my parent function values are the same. And then we're adding 4 to the y values, so my x values don't change. When I add 4, I get 8, 6, 4, 6, and 8. So let's graph it and see what's happening. So plotting my parent function. And then plotting my new one, -4, 8. negative 2, 6, 0, 4, 2, 6, and 4, 8. So there's my new function. Notice that every single point, what happened to it was it shifted up 4. So this, oopsie. So my transformation here would be a vertical shift up 4. Okay, so looking at my next one, notice we still have absolute value symbol. Here's my parent function and my new function. We are this time subtracting 4, which means we will be subtracting 4 from the y values. So my table still the same here. And then my x's are staying the same. And we are subtracting 4 from our y values. So that's going to be a 0, negative 2, negative 4, negative 2, and 0. So plotting my parent function first. And then plotting my new one, negative 4, 0, negative 2, negative 2. Let's go back. That should be, and that's right. Okay, so then we have 0, negative 4, 2 at negative 2, and 4, 0. Okay, so notice here that my points went down 4. So this is a vertical shift down 4. Okay, so now looking at the next one, notice the difference on this one. We're still dealing with plus 4, minus 4, but it's on the inside of your absolute value bars. So in order to find your values in your table G, if it's on the inside, you're actually going to be doing the opposite. You're going to be subtracting 4 from your x values. Okay, so this is my parent function. And then we're going to subtract 4 from our x values. So when I subtract 4, that would be negative 8. That would be negative 6. That would be negative 4. Negative 2 and 0, and then my y values are going to stay the same. All right, so plotting my original parent function, negative 4, 4, negative 2, 2, 0, 0. And then we're going to plot our new function. So negative 8, 4, -6, 2, -4, 0, -2, 2, 0, 4. So notice what happened whenever we added 4 there. It is shifting to the left 4. So this would be a horizontal shift. Left 4. So anytime we're adjusting the X, it's always the opposite. Okay, so this one here we have the parent function, and then notice this one is X minus 4 inside your vertical bars. So on this one, we're going to be adding 4 to the X values. So completing your table, parent function's still the same, 4, 2, 0, 2, 4. We're going to be adding 4 to our X values. So when we do that, that's going to become 0, 2, 4, 6, and 8. And then our Y values will stay the same, 4, 2, 0, 2, 4. So we're going to plot our points. So parent function, -4, 4. All those points are still the same as all the others that we've been graphing today. So that parent function is very important that you know. And then we're going to plot the new ones, 0, 4, 2, 2, 4, 0, 6, 2, and 8, 4. So notice on this one that it's going to the right. So it's a horizontal shift right 4. Okay, so now let's take a look at the back. So we're going to be describing the transformations from your function f into your function g. So looking at number 1, it says g of x equals absolute value of x minus 15. So if you remember what we just found out, if we are subtracting inside the parentheses, it's the opposite. So it would be going to the, let me go back. It'd be going to the right 15. And then this next one, notice we have f of x. That just means your function f, which is your parent function. You're going to be adding 1 on the outside, which means you're going to be going up 1. And the inside of your bars here, remember on the inside, if it's multiplied, it's the opposite. So instead of multiplying by 4, it's going to be multiplying by a 4th. It's the opposite. So this is a horizontal compression by 1/4. So remember, it's a stretch if it's a something greater than 1. If it's in between 0 and 1, it's a compression. Notice on 4, we have f of x, which is our parent function, but we're putting a negative on the outside. That's going to be a reflection over the x-axis. And then we have 6 on the outside. That is a vertical. Since it's greater than 1, it's going to be a stretch by 6. Looking at this next one, we have function f, which is the same thing, absolute value of x, and then we have 1/7 in front, so that will be a vertical This will be a compression by 1/7. So if you're multiplying by a number on the inside, it's going to be horizontal. If you're multiplying by a number on the outside, it's going to be a vertical. Compression is in between 0 and 1. Stretch is greater than 1. All right, so we're going to identify transformations from the graph. So we're going to write out the verbal description of the transformation, then we're going to put it in function notation, and then we're going to actually write the equation. So verbal description, first off, you have to remember what our points are. So if you need to, you can draw out your parent function. That might be helpful. Okay, so notice that our point on our V shifted left 1. And so did the other points. Notice it's left 1, left 1, left 1, and so on. So it looks like that's all that happened here. And so we are going to use function notation. So if we're going left, remember that's always on the inside and it's the opposite. So if it's a horizontal, it's opposite. So you should be adding 1 on the inside. So instead of putting f of x, you're going to put f of x, and then inside the parentheses, you're going to put 1. That's what it means by function notation. So you're going to be using function f, which is absolute value of x. You're going to shift it left 1, which would be plus 1. The equation for function g would be absolute value symbol x plus 1, and then close your absolute value symbol. Okay, so now let's look at the next one. Again, it might be helpful if you plot your points. 1, 2, 3, 4, 1, 2, 3, 4. So that way you can kind of compare it to your parent function. Okay, so notice that we do not have a vertical or horizontal shift. So it's not going left or right, up and down, because the point of the V is still at the origin. So that looks like we're either going to have a stretch or a compression. So we need to check that out. So normally I have a point of 2, 2, but notice that it's 2, 1. So if it's 2, 1, that means it's taking half of your y values. So that would be a vertical compression by a half. And then the function notation for that is you have your function f, which is your absolute value of x, and then we're multiplying that by a half on the outside. It was a vertical compression there. Okay, so the equation for that, we're using g of x equals 1/2, and then we're taking the absolute value of x, which is our parent function. Okay, looking at the next one, again, it might be helpful if you plotted your parent function or just look at your parent function on your notes. And notice that our points have just been reflected over the x-axis. So reflection over x-axis. Your function notation, remember that's just the negative in front, so negative f of x, and then your equation would just be negative absolute value of x. So a reflection over the x or the y-axis is the negative on the inside. Okay, so long lesson. We split it into 2 days, so we're doing this 2 separate days, and then you'll just get 1 assignment for this whole thing. Let me know if you have any questions.